The second largest lake in Turkey is going to be gone by 2015. You can see the sort of salination and dust from all of that. It's gone from 216,000 hectares down to less than 30,000 hectares. The bottom left-hand corner, that's Cyprus. That's a key river in Cyprus. In Cyprus, the demand is for 100 million meters cubed of water every year. The availability for the last 3 years was 24, 39, and 19 million cubic meters of water. Water is being shipped in from Greece to Cyprus. In Crete, the aquifer has dropped 15 meters since 2005. Bottom right-hand corner is a power station in Turkey. It's indicative of the kind of coal-fired power stations which require water for its cooling and which face shortages and shutdowns when there is drought. This is already the situation. This is not in 2030 or in 2050. This is now. A few weeks ago, March 18th, the executive director of the European Environment Agency said this: Europe does not have enough water to sustain its current consumption. We're in a pretty serious situation at the moment. So, then add the impact of climate change on top of this, which is probably the next kind of chapter in what I want to get across to you. It doesn't really matter what you're looking at, apart from the fact to take account of the really dark red stuff in South and Southeastern Europe in the bottom two pictures. They're two different models from IPCC scientists. And they're showing us the future return period of droughts with intensity of today's 100-year events. Basically, what that means is the dark red is showing us that by the 2070s, less than every 10 years, there will be 100-year style drought events which we've experienced historically. That's quite significant if you layer that on top of what I was just outlining in terms of how we are mismanaging our water already. A decrease in runoff by 20% by 2020. A decrease in runoff of 30% by 2050, 36% by 2070. Decrease in summer flow by up to 80%. So my argument to you, I would suggest, is climate change is a kicker that will really kind of burst these bubbles of water, the asset that we've been using quite freely until now, perhaps for the past 90 years, to generate wealth, both in this part of the world and elsewhere. Of this situation, provided those with water surplus can grow the food that those with water scarcity need. Otherwise, we'll see more of these pictures on the bottom right-hand side. If this bubble bursts for energy, I already mentioned the IEA scenario of 45% increase in energy demand globally by 2030, which, by the way, the IEA say is patently unsustainable. Water consumption for energy is expected to grow 130% in Europe by 2030. Potential for hydro falling by 50% by 2070. The implications should become clear without me having to kind of draw out the necessary details. I've mentioned about the biofuels issue. That bottom picture is a desalination plant. And I'd just like to kind of pause on this one for a moment. Desalination is seen as kind of a potential sort of solution, a silver bullet, a saving grace. 13% of global capacity for desalination is in Europe. The market's increasing 12% a year, expected to accelerate, $56 billion a year being invested. But the energy costs are the primary barrier to increasing desalination as a water solution. They are still high. They are coming down, but still high. And also, don't forget that desalination is probably okay if you're a city by a coast, but if you're a city inland, think of the transportation costs of that fresh water. But more importantly for this region is to overlay the challenge that there's actually a very poor regional energy market in this part of the world. There's very little kind of surplus energy that's sold between different countries. There's mini hydro rather than max hydro. So there's a real need to fix the energy arrangements to enable desal to become a real option in this region. For example, London won't have a desal plant because it requires too much energy and the power supply is too thin. So to sort out the freshwater solution, if one takes a desalination route for this part of the world, one also has to look at the regional energy market that can provide the power for those desalination plants. Or you could be in this kind of rather ironic situation of a high-carbon power station providing energy for a desal plant to provide the water for the high-carbon power station. Going to get caught in this rather ironic loop. Similarly, if we carry on those projections of what the water shortage will mean for cities, there's Istanbul, Athens and Barcelona. I've mentioned some of the shortages they face already. Those dryouts, those costly emergency operations, the politics of that will be quite interesting. And at what stage does one suggest that there's a risk of failure in a particular city, particularly inland? Now, the transboundary issue is also terribly important. This is a part of the world where 90% of the territory lies in international river basins. Cooperation is essential. And this is cooperation between recently formed, relatively speaking, nation-states in the Balkans. There are 13 transboundary river basins in this region, so countries such as Serbia, Montenegro, Albania and others will have to work in unprecedented levels of cooperation in terms of water and energy management to solve this problem. But I've saved the best till last. This is probably the biggest challenge of all. Now, this is the Alps. Springtime glacial melt into rivers from the Alps provides 40% of the fresh water for Europe. Think of it as a kind of water bank. Alpine glaciers, as a result of climate change, are losing about 3% of their pack ice per year. They lost 10% in 2003. The best modelling, i.e. the most conservative modelling from IPC scientists, suggests these glaciers have gone by the end of the century, if not sooner. We'll see flooding in the short term and no ice in the long term. That's just not a European problem alone. There are many parts of the world where glaciers act as water banks. The Himalayan Tibet glaciers provide water for 2 billion people, about a third of the world's population, through 7 major rivers, including the Ganges, the Indus, the Mekong, the Yangtze. Glacial melt in the Himalayan Tibetan plateau in the 1990s was ×3 the rate of previous decades. Modelling suggests those glaciers are gone by the end of a century. The Millennium Ecosystem Assessment calls it an ecological disaster. Central Asia, a bit closer to home, to here, almost all the fresh water in Kazakhstan, Kyrgyzstan, Tajikistan, Turkmenistan, Uzbekistan come from the permanent snowfields and glaciers in the mountains of Kyrgyzstan and Tajikistan. Satellite imagery shows a 33% shrinkage of these glaciers since 1944. Again, modelling suggests gone by the end of the century. So, on that rather bright note, I shall end my presentation, but I hope you get the message that any discussion about climate involving energy technologies, involving food, involving national security, has to involve a discussion about water. There is not another conference with another set of intelligent, brainy people solving that water challenge separately. These things are connected. There's my final thought for you. Thank you very much.
Thank you very much, and sorry in the beginning for introducing you as 2 other people and creating an identity crisis. This is...
I was used to it when you taught me.
Right.